I'm going to explain how to do problem number 17. In problem 17, we are going to look at how to find the force that each other exerts on another. To start this problem, you will first need to figure out the formulas necessary to solve. We will start with the formula F equals K Q1 Q2 over D squared. We are then going to replace Q2 with Q minus Q1 because the total Q equals Q1 plus Q2. We then receive this formula, which is F equals KQ1 times Q minus Q1 over D squared. To get this to equal 0, we set it up as Q1 squared minus Q1Q plus FD squared over K is equal to 0. We will now place this into the quadratic formula and substitute our numbers, which gives us this. Q1 is equal to 1/2 90.0 times 10 to the negative 6 coulombs plus or minus the square root of 90.0 times 10 to the negative 6 coulombs squared minus 4 times 12 newtons times 0.280 meters squared all over 9 times 10 to the 9th newtons times meters squared per coulomb squared. After doing the calculation on this, you will receive that the charge on one sphere is 88.8 times 10 to the negative 6 coulombs. With this, you can find that the charge on the other sphere will equal 1.2 times 10 to the negative 6 coulombs. The problem then asks what would happen if the force were attractive. To do this, you will substitute a negative 12.0 newtons for Q1 because an attractive force only exists between positive and negative charges. We will then again substitute our numbers into our quadratic formula and receive this equation. After calculations, you will receive that the charge on one sphere is 91.1 times 10 to the negative 6 coulombs, and the charge on the other is going to be 1.1 times 10 to the negative 6 coulombs.